I would have written that out. So from K to L, positive acceleration or negative acceleration?
Positive.
It's one of those two.
Positive.
You're positive it's positive?
I'm just saying positive because I think it's positive.
Why do you think it's positive?
Honestly, I'm lost in the
I think
sauce.
it's
so-
negative.
I think it's negative.
All right, why do you think it's negative?
Wait, you said from K to L?
K to L, what's going that way?
Cause there's
Oh.
friction right there.
Yes, there is friction. And? Coy?
He's
Pushing in the opposite direction, but it's positive acceleration.
Yeah. Friction tries to oppose the motion. So the puck's going that way, so the friction is acting on it that way, slowing it down.
Okay, so if it was negative going this way, that means it's positive going this way? Is that what you're trying to say?
That's the way it works out here. That I'll go over this again in a slightly different way, but it's moving in that direction. It's moving in the negative direction and slowing down. The acceleration has to be the opposite. Acceleration is positive here. So from K to L. What about from L to M?
Positive.
Why? Just felt right?
It's constant.
Yeah, because we need to
constant.
fill in the positive box.
Oh, yeah, probably not a good rule of thumb. If you do the ball problem on one of the videos, there are some not applicable places where it's, yeah, you're not necessarily filling in.
Well, wouldn't it just
Wouldn't it
still be
said
going
from
that way?
L to M?
Yeah, in this region right here.
It's constant though.
It's constant,
Yeah.
no force.
Acceleration 0 again. So not including L, because L's included there, but it is including K. And then in this region right here,
Oh,
Would it be M, not A? Because it's going, it starts.
oh, thank you very much. Yeah, that is not A there, that is M.
That looks like a set.
I apologize for that, thank you for catching it.
that's why I'm.
Mason?
You forgot H to K.
Zero H to K.
I forgot H and K. I did. Squeeze that in here. Not including K. All right, and the last bit, or things,
Wait.
other things I forgot?
We already included H in something else, in the negative.
Thank you very much.
Would the M to N be positive again?
It would. Not M, including N. Now, with the 4 different displays of how to express it, this is just 2 of them. I find that for a class this size, there'll be at least one person who does each kind. So, you know, you pick the one you're comfortable with, or, you know, you pick the one that your brain's working on at that moment. So over here, acceleration is 0 from A to B, so 0 from A to B. From B to C, it is positive. And then from C to D, between C and D, it is negative. Got too many pluses in there. Those should be combined. At D to E, it is negative. Wait, C to D was 0. Yes?
I'm confused as to why you're saying B and C is positive, because over there it says it's negative.
Because, just cause,
That's not good enough for me. I'll struggle.
all right, so you want me to actually put the right answer down?
Yeah, oh, okay.
I
was
didn't know
making
you were
sure.
that person.
I'm just trying to make sense.
So, no, you're right, B to C was negative. Oh, there we go. Well, I made another mistake there. All right, and then C to D is 0. D to E is negative. Man, I should have done a grid. All right, E to F is 0. F,
F to H is negative.
then H to I is, oh, actually it's H to K is 0. Not including K. Then K becomes positive. Through L. And then L to M, including M, is 0, and then it's positive again. So, in lieu of some careless error, there's the answer. Questions? Cooper?
So, I'm confused as to why if we're dealing with velocity, velocity is displacement over time, right?
Right.
So if the displacement is positive from A to M, why does the velocity become negative from G?
All right. Because of the default. This by default is the overall, and these by default are the instantaneous, and that's the difference.
Okay, so is it, so like if we're moving from G to I, that's negative displacement, which is Y, or like G to H, I mean, or like H to I.
Yeah, H to I.
As we move along this way, we're moving negatively instantaneously.
Yeah, so the instantaneous velocity, the instantaneous displacement is negative all in this
Okay.
coming across this way. Other questions? All right, let's take a look at this slightly differently. I think most people are pretty much are okay with figuring out where it's going to slow down. So I'm just going to say it starts out going 20 meters per second. These are velocities I'm writing down. It's cruising along at B, it's going 20, and then it starts to slow down. So let's say it's doing 15 here. It gets to D, it's going to slow down again. So let's say it's going, well, it's 15 when it first gets there, and then it slows down to 10. At F, it's still going 10, and then it goes to 0. Negative 10, because it's going the other direction. Negative 10 here. It slows down because it's hitting friction, so negative 5. It's going negative 5 at this point, and then 0. So these are just made up numbers, but it shows slowing down. In other words, getting closer to 0 any place that it would get closer to 0. So now, if we look at change in velocity, what is the change in velocity here?
0.
And, all right, so my change is 0. What about here?
5. Negative 5.
Yeah. Sign, the order matters. It's final minus initial, so negative 5. Here?
0.
Here?
Negative 5.
Here?
0.
Here?
Negative 10.
Here?
Negative 10.
Positive 10.
0. 5. Negative 5.
Negative 5.
It's positive.
Positive 5.
Oh, sorry.
0. Positive 5.
All right. My acceleration in this region between B and C is negative. My acceleration between D and E is negative. My acceleration from F to H is negative. My acceleration from K to L, positive. My acceleration from M to N, positive. So it matches. Another way of looking at it, as you're checking yourself, and again, I don't want to use that on this board yet. Purple. When velocity and acceleration are opposite signs, it's slowing down, which happens in this region right here. Yeah, Jaquan.
Could you like briefly explain how K and L is positive acceleration when there's friction present?
Acceleration is the change in velocity over change in time. Change is final minus initial. So this is final velocity minus initial velocity over time. From K to L, my final velocity is -5, my initial is -10. So this is -5 minus -10, which is -5 plus 10, which is +5. There's a positive change in velocity.
Okay.
Okay. So when it's going over the friction area, it's slowing down. From when it hits the box, it's slowing down. When it hits the wall, it's slowing down. It slows down there. Oops, wait, sorry. It's not slowing down there. It slows down here and it slows down here. In this region right here, velocity and acceleration are the same sign, it's speeding up. Because it speeds up as it's a maximum deflection of the wall, and now it's going from 0 to something. So it's speeding up here. It's just an extra check. Questions to here? Now, the next step on something like this, and I don't ask you to do this on the master set, but I will on the test. Sketch a graph of position, velocity, and acceleration. First time. I think this is probably going to be easier to manage here. So I'm going to erase that. Now this is a sketch. What I provide for you is a graph with the letters. Let's do it over here. So A, B, C, D, E, F, G, H, I, J, K, L, N. This is position, reverse time. I know my position is 0 at D and J. So D and J. So I know my position is 0 there and there. I know it's negative beforehand. Positive in between. And I'm doing a dotted line here because it's going to change as we go. But at least I have a really rough sketch here, and it matches what I have as an answer over here, where it's positive and where it's negative and where it's 0, which is one of the checks I do. Velocity versus time.
Like you want us to do a graph for like all?
For position, displacement, and acceleration. Sketch a graph. All right, my velocity is 0 at G and N. And I know it's positive up to G and it's negative elsewhere, so just a really crude sketch here. So at least it matches positive, negative, 0 from what we had before. And then acceleration. And there's a reason I crammed them all stacked like that. and acceleration is 0 from A to B, not including B, from between C and D, between E and F, and then from H to K. And then between L and M. Like them. Between L and M. All right. So I've got my crude sketch here. Now we need to fine tune it. Oh, well, I actually know it's negative here, so I'm just going to put a little dotted line here, dotted line here. Now we fine tune it. If I have a graph, y versus x, how do you find the slope of the line?
Rise over run.
Okay, so I got some point here, some point here. I do my rise, got my run. So my rise is just changing whatever those y coordinates are. And run is just my change in my x coordinates there. So my slope is rise over run. Yes, Kristen?
So you are going off those lines off of what you put up there and
Yes.
on the thing. So I don't know if I'm just stuck in math 171, but isn't it if you include something or you don't exclude it depends on if you have a empty circle or a complete circle, like a filled in circle?
Yes, and so one of the things, it's a sketch, and also I need to draw a continuous line somehow. So this will, hopefully I'll address those points.
Okay.
So if I say that my velocity is my change in position over change in time, well, that's just my rise and run if I just happen to have a position versus time graph. My rise would be my change in position, and my run would be the time, change in time. In other words, this should be the slope of this. So at G, when my velocity is 0, that means my slope of my curve up here needs to be 0. And what does a line of 0 slope look like? Yep. So when you have a curve, you draw a tangent line. So at G, if I draw a tangent line at G, it should be flat. So it peaks at G. That matches what I have here. At N, it's also 0, velocity is 0. So my graph here actually shouldn't trail off like that. It needs to level off. So that my tangent line here has a slope of 0. In this region right here, my slope is negative. Sorry, try that one again. My slope is positive all along here. My velocity better be positive. My velocity is negative all along here, so my velocity better be negative. So that seems to match so far, but this seems to be, at least in terms of sign, that curve, those match. Acceleration is the change in velocity over the change in time. In other words, it's the slope. If you happen to have a velocity versus time graph, this would just be the slope of that. Well, my acceleration is 0 here, which means my slope needs to be 0 here. So anywhere, actually, my acceleration is 0. My slope of this needs to be 0, so that's between C and D also. Between E and F. From I to K. From L to M. I'm not quite sure what's going to happen in there. I might, again, I might have to shift. I recommend not doing this in pen. That you cannot erase. my acceleration is negative, so my slope better be negative here, so something like that. And my slope is negative again, so I got another little transition there. My velocity is 0, so I need to make sure I hit 0 there. So my slope better be negative. And then from K to L, I have a positive slope. And then from end to end, it's positive again. So I've got a slightly better tune here. And then we can come up here. I know that if my velocity is constant, my slope is constant. So from C to D, it better be constant. From A to B, my velocity is constant, so my slope here should be constant. And it changes to, so in this region right here, it goes from that constant slope to a smaller constant slope. So let's adjust that. And then E to F, it's constant. Then I got this big change here. I know it peaks at G. And then I to K, this is constant, so. And then L to M is constant. And that's a crude sketch of, let's go ahead and fill in the dotted lines here. All right, before I address Kristen's concern earlier, any questions? All right, so let's just zoom in on this region right here, because at B, it is, my acceleration is negative, but right before it, it's not. So that's A and B. It's a crude sketch, so there's a certain amount of close